Good morning, good evening, good afternoon. Thank you for joining. My name is Derek Hansen. I'm an attorney for the United States National Oceanic and Atmospheric Administration, or NOAA. I also have the pleasure of serving as chair of the Law and Policy subgroup of the Data and Knowledge Working Group in GEO. And I want to thank the Dialogue Series leadership, Bente and Marie-Francois, for inviting us to help with this topic today. And I want to thank as well the GEO Secretariat team for all their work for helping put this together. And I want to thank my fellow members of the Law and Policy subgroup who helped put this together, and some of them are speakers, and then most importantly, our speakers for their time and sharing their expertise with the group here today. I hope you find this interesting, and I hope if you do, that you'll consider joining us in the Law and Policy subgroup. Feel free to reach out to me or the Secretariat team if you have any interest. We cover these types of subjects monthly and try to provide support to the GEO community on law and policy aspects related to our work. This session or this dialogue is going to discuss various issues related to governance, licensing, and ethical challenges shaping how Earth observation data is produced, shared, and used for decision making. Also, as AI increasingly drives critical decisions, questions around trust, accountability, and liability become urgent. So today we have experts from law, ethics, machine learning, Earth observation coming together to discuss a number of these issues. And I want to make sure we have plenty of time to hear from the speakers and to hear from all of you. So I'm going to start us off with Jordi Sandelinas. Jordi is going to present a use case about decision support for shipping goods and the need to mix several types of interoperable data, leading to the need of managing licenses in a complex workflow. Jordi is a space and drone law practitioner, university lecturer, and entrepreneur. He's the founder of Image Sea Solutions, a space-to-ocean initiative, and he aims to drive legal interoperability and innovation in satellite, maritime, and AI-driven ecosystems. He's also a longtime member of our Law and Policy subgroup. So without further ado, I'll turn it over to you, Jordi.
Thank you, Derek, for giving me the floor. It's a pleasure to be with you all. I'll proceed with presenting my slides. Thank you. Well, the objective of my presentation is to open the floor and the debate on open data and value added information and the licensing issues I have encountered while working at Image Sea Solutions. So that's why I have framed my presentation on the name From Data Integration to Interoperability, highlighting the importance on the format of data and how we can use this data, and when it's open, then we have, and also when we have added some value-added information and where some proprietary data, how we can merge and harmonize this framework, and the difficulties and the issues I encounter on a daily basis. So Image Sea Solutions is a company that operates across, as I said, multiple data environments, from cybersecurity to the application of satellite imagery to drone imagery, and also gathering networks from different shipping companies, and that help to locate the ships and that help to predict different variables such as the climatology and the prediction of arrival of the different ships and the issues that can encounter while en route. So data, as I've seen, can be technical compatible but legally unusual. I've encountered different issues in this case, also semantically inconsistent, because one can understand the notion of ocean wave, but also another company calls it length weight. It depends on the region as well, and from a technical perspective, this data can be inconsistent. So the integration of data is crucial in order to allow the companies their decision-making process and to smooth the operations, because one container that arrives late to the destination can entail the lack of acceptance of that container by the recipient company, because alleging that the merchandising will not meet the criteria and will not come to the stores on time. So that brings and creates damages from an economical perspective and also from a reputational perspective. So AI also has added some extra value to the management of all this data, and we have encountered some legal issues in this regard, not only from the artificial intelligence perspective and management of data, but also the data per se. So there are some a lack of compatibility issues regarding the different types of licensing. There's some use restriction and some distribution of rights. So as you know, Barcelona is one of the main ports of the Mediterranean. Just some fun facts. There is from a logistic perspective, it manages like 69.7 million tons of cargo that was calculated and from data coming from 2024, 2 years ago. And also there are like 3.88 million containers coming and departing from Barcelona, which entailed an 18% growth. And there are different specialized terminals across different surface, a total surface of 800 hectares. And the market of the Port of Barcelona is addressed and has access to more than 400 million Europeans and has connections with all over the world. So, as I said, Imaging Solutions is a space-to-ocean integrator that integrates maritime intelligence platforms, satellite Earth observation for maritime monitoring, also drone-based data with an objective to minimize the regulatory risk and that maritime shipping companies might encounter. And of course, it's a company. If we could frame it in in 2 words, that would be a company devoted to maritime awareness and risk mitigation. So we use data to allow shipping companies to make the best decision as possible to support their daily task. We require this data to be interoperable so shipping companies can optimize their routes and avoid miscalculation of route excessive stops. Also, we use that data to make the right prediction of the climatology and the climate conditions that a ship will encounter. Also, knowing the port congestion is important, because then we can calculate how many stops the ship will make, and if the shipping activity will arrive late, the boat and the ship will arrive late, and what will be the estimate time of arrival. So also we provide data that help companies to comply from an environmental perspective and to that also are capable to control the emission of fuels. And so there are basically 3 types of data according to the right of such data to be applied, like open data, which is free data and you can use it freely in your company. You have basically free distribution rights. Commercial data, which is the data that has like encounter a value added process and then it has a market price. And also drone data that has a proprietary value, because it's not is data captured by a local company and is subject to private law mainly. So again, this distinction: open data has broad reuse rights and is freely accessible. Also, commercial satellite data that has some certain contractual restrictions, and drone data. And this integration of these 3 types of data causes like a licensing friction, as I as I referred before. So there's this paradigm on how to combine open, commercial, and drone data, and the legal questions that I always ask to the company and to my colleagues: who owns the output of the data? Can it be commercialized? And all the derivative works derived from such data and are free to use, and under which conditions. So the contract solution, the private agreement is fundamental. So the license will bring, according to the daily practice, will bring the answers that we might ask. So the data workflow goes and follows this route. Step one, we acquire the data or we license the data to the client. Then this data has to be harmonized. From a legal perspective, this data has to be delivered to the end user with no legal, no technical, and no semantic issues. Therefore, we align it. We align the data, and we can consider interoperable. So we can share this data from one company to the other, from one region to another. So we make sure then that we and 100% sure that there will be no further issues of misinterpretation or misuse of rights. So AI-driven analytics brings an extra layer of concern, because AI tools and AI applications have to be capable enough to integrate and to interpret this data from a practical perspective, because data can be shaped in different formats. So this will bring the right, a correct administration of such data will allow the best decision support as possible. There are also some standard and protocols. Nowadays, we work from an international perspective with protocols, because even though they are a soft law, considered as a soft law documents, from a customary perspective, they can become source of law. So I always refer to the International Standard Organization, the Open Geospatial Consortium, and the Group on Earth Observation, the group I belong. And so if the right standards are developed, then we can ensure a smooth application of this different type of data. So the contract solution is the one I referred to, and the importance of a private agreement, whether negotiated or the online agreement, if we consider an adhesion of contracts. So it's important that the contract enhances and stresses all the legal aspects that are considered important as per that operation. Again, the issues, we encounter some technical formats, as I referred, some semantic formats regarding the meaning of data and how we name such data. From a legal perspective, we require some compatibility between licenses, and these layers must be aligned for the right operational use. In this regard, Imagy Solutions does not own the data, does not appropriate the data, but integrates the technology and allows maritime companies to administer such data and to allow their decision-making capacity on a daily basis to help overcome their goals and practices, right? So thanks to our technical partners, we can facilitate data to allow the smooth operation of navigational routes, and also data that is competent and reliable enough to predict climatology issues, so that we avoid en route problems in this regard. Again, from a legal perspective, I would stress and hence the importance of the EU legal framework regarding open data. So open data is free, but of course is subject to certain laws. Some regulations that are applicable are the following. In 2021 was published the Copernicus Open Data Policy that regulates different programs, and it's called the EU Space Program. Act in this and regulates and refers to ECNOS from all is the program that refers to satellite navigation, and Copernicus, which is the program that refers to Earth observation. Also, there are other directives that I haven't mentioned here, such as Inspire Directive or the Metadata Directive. Some of them are no longer in force. And of course, there are other very relevant directives and regulations, as you see here, the Open Data Directive, the Access and Use of Data Act, that are relevant to this presentation. From an international space law perspective, it's relevant to understand and know the existence of the Outer Space Treaty and the 5 other treaties that are pertinent to satellite data, and satellite data, as I said, and concretely Earth observation and remote sensing data is of free use and has to be delivered under a non-discriminatory access. So licensing is, I think, the key point in this regard, and I hope I have given enough light to move on with the next speaker. And I'll thank you for your kindness, Derek, and for the opportunity to present my project here. I give you the floor. Thank you.
Thank you so much, Jordi. That's a great introduction to the topic here, and great to hear from you again as a longtime member of our subgroup. So thank you. I'm going to put in the chat. We have a link to something that we did together, Jordi and I, and the rest of our subgroup a couple years ago, was to develop licensing guidance for data for GEO members. So of course, data was founded, or GEO was one of the foundational principles was full and open access to Earth and observation data. As Jordi mentioned, licensing is an important part of making data available in today's era. And so I'll put in the chat, encourage you guys to take a look if you haven't heard of it yet or had a chance to review. Our next speaker is Jean-Philippe, also a member of our subgroup. Jean-Philippe is a senior geoscientist, climate change expert, and data policy advisor at PMOD WRC in Davos. He's a vice chair of the IEEE Switzerland Foundation and an honorary scientist at the University of Beira Interior in Portugal. With over 20 years experience at the intersection of data strategy, analysis, and policy, his work encompasses geophysical policies, sea level rise, solar forcing, and data governance. As an advisor to GEO, again in our law and policy subgroup, he's dedicated to implementing fair principles to ensure that climate observations are robust, interoperable, and scientifically sustainable. Jean-Philippe is going to talk about the need for managing liability for Earth intelligence, as fake or inaccurate products can have major political or economic impacts. Jean-Philippe, over to you.
Thank you, Derek. I'm just asking Felipe if you can share the slide, please. Okay, thank you very much for this nice introduction, Derek. Today, I'm going to speak about a concept, geodata liability. It's basically a risk that is hiding inside any data pipeline that power policy and climate economy. This is just at the level of concept. And this talk is an overview, and hopefully we'll carry on the debate through the advisor and the expert group at the GEO. So that's roughly a scheme of the processing chain, that's from raw data to policy. Every climate product, carbon credit, risk model, and policy is an output of this chain. Raw data are recorded, collected, managed, and go through quality check and pass through models until it reaches a decision maker. This chain is designed to be robust. It relies on protocol metadata standard, FAIR principle, the same promoted by the various subgroups of the GEO. But it has a critical weakness. At no point does anyone own the liability for what comes out at the end of this chain. When the data is wrong, no one is accountable. Okay, just to illustrate this concept, I look into the literature, and there is an example, or close to geodata liability, is a phantom credit scandal. This, in 2023, 2 journals, Deep Sight and The Guardian, revealed that 90% of the rainforest carbon offset certified by a well-known certifier were essentially worthless. Geospatial data used to estimate deforestation risk had never been validated. AI-powered model and black box amplify those flow inputs. Thus, Bayer, big corporation, assumed the certification chain was robust and independently verified. It was not. Liability fell entirely on them, triggering a chain of legal events and a loss of reputation due to a greenwashing scandal. Thus, this is an example of how the concept of geodata liability could be developed further. Thus, we have AI embedded in the process, the chain of processes, the one I showed you before, and it's currently all those AI model we all know are currently deployed in the data pipeline, but without the rigorous standard that we apply to physical measurement. Any geophysical instrument or scientific instrument in general must meet strict uncertainty and traceability requirement. An AI model learns statistical association from training data. It can produce, unfortunately, artifacts, inherit training biases, or generate output that look like a genuine climate signal, but unfortunately, it is biased. Because this AI hallucination. Thus, without physics-based validation, there is no way to separate a real signal from an artifact. And the question becomes, when an AI-derived climate product causes financial harm, who is liable? Right now, there is no formal answer. An overview of this definition, of course, it's in debate. It's not. It's a work in progress, I would say. This is a systematic, geodata liability is a systematic global risk and not an isolated technical issue. Financial market, government, insurer, and other businesses are increasingly making trillion-dollar decisions based on AI-driven Earth observation data. If that data is not validated, the exposure is enormous, and it touches all the sectors I just mentioned, green finance, and also sovereign policy. Therefore, there is a need for a new framework combining physics-informed deep learning, thus the mechanical in the AI black box, with metrological standardization. The goal is simple: move from open data, which imply open risks, to trusted data, which provide accountability. In this slide, there is a question, another one. It's how to attach to this geodata liability a standard or multiple standards. Thus, we need the product to be traceable with an uncertainty budget. And this is technical. There are two parts. There is the legal part that we discuss in the GEO, and also the technical part, which will be how to attach traceability, conformance, data provenance, and this uncertainty to this standard. And finally, geodata liability is not a barrier to innovation. It is so far a concept which aims to make a $1 trillion digital climate economy possible and trustworthy. Green finance depends on verified data quality. Climate policy depends on auditable evidence. Parametric insurance also need that kind of safety, I say. Thus, none of that work without accountability in the data chain. Thank you very much for listening.
Yeah. Thank you so much, Jean-Philippe. That was a great overview of an important and emerging subject. And I'll just make another advertisement for our subgroup. This is a topic that we are actively considering as a priority item for our work plan this year. So if anything you heard from Jean-Philippe sounds like something you'd be interested in, again, please consider joining our subgroup. Our third speaker is Thomas, also a participant in our subgroup. Thomas is an international lawyer, scholar, and strategist with a background in international and corporate law, global governance, regulation, rule of law, and development. He has worked in diverse sectors, including academia, law firms, government, international organizations, and NGOs. He's a member of the Faculty of Law at, I'm going to get the name wrong, Thammasat, thank you, University in Bangkok, Thailand, and has taught in the Rule of Law for a development program at Loyola University in Chicago School of Law's Rome campus since 2011. So he truly is an international lawyer. From 2020 to 2024, he was an executive director at the Rule of Law program. His research focused on the intersection on international rule of law, global governance, development, and regulation, with extensive experience in the nexus of human rights in international environmental, natural resources, and agro-biodiversity law. Thomas is going to open the landscape to a global governance, legal, and ethics framework, linking the previous use cases and ethics considerations that you're going to hear after his talk. So, Thomas, over to you. Thank you.
Super. Thanks, Derek. Good to see you again. So yeah, I'm going to talk. I think it flows nicely from the last two presentations because, as Derek mentioned, my background is in international law and have a particular interest in international regulation, and have been looking at the question of AI for AI's use on Earth observation data, and what legal and ethical and regulatory challenges stem from that. So if you go to the first slide, please. Just so we can have a big picture of what the different potential uses of EO data are. As you can see from this list, everything from disaster relief and humanitarian and relief, migration, urban planning, pollution control, biodiversity monitoring, endangered species, climate, oceans, all these different fields raise distinct regulatory and legal challenges in terms of the use of the data. Some of the regulatory and ethical issues that have been identified in this area, there's been a fair amount of research done on the ethical principles that might apply to the use of AI for Earth observation data. And some of the consensus principles that have been identified include issues of fairness and inclusivity, the accuracy of the data, and then transparency and explainability. So a term that's frequently used to describe how AI systems operate is that it works as a black box. It's difficult for people who don't design the systems to understand what's going on within the systems, and issues of privacy. Now, all of these issues are kind of generically applicable to law and regulation in our societies. But when you're talking about the use of AI tools and being applied to Earth observation data, there are distinct considerations that come into play that are not always immediately obvious. And trying to understand how these general principles that people will generally accept as valid in terms of how we govern our societies and how business and individuals work and live in our societies, when we're talking about how they should be defined in the specific context of Earth observation data, and the use of AI for those for that data, there is a need to really explain and to explore what measures need to be taken to address these issues. So one of the things that I've been working on is to try and break down what the issues are. And there's been a lot of work that's been done, as I said, on exploring these general principles and how they might affect the use of AI in this context. But what I've found is that they tend to conflate the production, the use of AI in the production of data and the analysis of data from the use of data, and that there are distinct regulatory concerns that are involved in both of those areas. For instance, on the production side, there's real concerns about how the algorithms that are used to analyze EO data are developed. What goes into them? As I said, this black box idea. Likewise, who participates? Is there any ability of outside actors to influence those algorithms? So if we think practically about how these might be used, for instance, as I suggested, in connection with migration issues or in connection with disaster relief, do the people who are affected by the use of EO data in those situations, do they have any status? Do they have any stake? And can they influence what algorithms are developed and applied to make decisions about their lives and livelihoods and safety? What kind of privacy protections attach to the use of EO data? And does AI, how do AI applications address those privacy concerns? Questions about the quality control. Are the algorithms sound? Do they function properly? Or, as we widely recognize, are there hallucinations and other problems associated with it? And can these models be made explainable to the public? What kind of disclosure is required? The standards for that, there have been standards for explainable AI, but it's still very much in development. How do we ensure the integrity of the data? So once data is collected, who keeps it? How is it controlled? How does the application of AI tools to EO data affect the integrity of that data? And then likewise, security. How do these systems operate in a secure manner, in manner that would ensure that some of the other regulatory concerns that I mentioned above here are addressed? But aside from this production side of things, so kind of looking at it from the upstream side of AI's use on Earth observation data, what about the downstream use? When products are developed using this, what kinds of considerations come into play? And there are distinctive differences. So as Jordi and Jean-Philippe suggested, there is this question of liability standards. What happens if the AI tools provide wrong information? What kind of responsibility do companies have, for instance, if they're using flawed AI systems? And what kinds of due diligence need to be applied to be able to use AI applications on EO data and then make decisions based on that? What are in legal procedures, what kind of evidentiary standards apply if you are, let's say, in a legal procedure, if somebody wants to introduce into evidence EO data or evidence that certain EO data means something based on an AI algorithm? What are the standards that apply to those uses? And then how is the data made available? What are the conditions? So some of this goes to these licensing considerations, but we have open data processes. What are the standards for making EO data available, say, for training purposes? And then how does that intersect with some of the other regulatory concerns in terms of the development that I raised, privacy, for instance? And then ultimately, what kind of accountability and redress mechanisms are available in the event that things go wrong, and that there are mistakes made because of problems with the AI applications that have been developed? So in terms of thinking about regulation in this area, again, this is not atypical for the way new technologies develop or new problems that are identified for there to be a lack of recognition of the full range of regulatory options that are available. So in this case, what I see happening is that there's very much we're at an early stage where there's discussions about, okay, what kind of ethics standards should be applied to the use of AI for Earth observation data. But that will only work to a certain degree. That's a kind of self-regulation, or not even a very low level of control. But when you look at the potential risks involved, as Jean-Philippe suggested, there's a need to address the liability considerations. So there's over time, regulatory systems develop and harder forms of regulation emerge and become more salient. So we see there's already been industry standards developed. Jordi mentioned the ISO standards, and we've been talking about contractual and licensing instruments as regulatory measures. But in terms of the domestic law and regulation, in terms of AI for Earth observation data, there's really not anything that defines this area, and that some of the generic AI laws that have been developed in the EU and national level are very generic. They don't address the specific types of risks involved in AI for Earth observation purposes. So do we think about the development over time of international soft law standards, or even binding international standards? And when that might seem far-fetched at this point, but when we talk about the types of human rights issues that are involved in terms of the use of AI tools on EO data, that becomes a relevant consideration. So, but there are all sorts of limitations in terms of the different options that are available. Of course, ethics codes can be very general and vague in terms of the requirements. There are divergences in norms. There's all sorts of different normative frameworks that might be developed. Likewise, industry standards, they may not be very rigorous. Do they have the kind of legitimacy needed to address the full range of issues? What kind of commitment does the industry have to those instruments? And contracts and licensing agreements, are the full range of regulatory concerns able to be addressed through those kinds of contractual mechanisms is an important question. Then what about the international agreements that I described? Is there any political will for something like that? It doesn't seem that that's even remotely feasible at this point. What's the cost involved? And what is the complexity of developing an instrument or instruments that might deal with these issues? Given that there's a lot of national legislation being done, supranational in the EU, maybe regional initiatives, how would those be harmonized, and other approaches that could be taken to harmonize these different regulatory approaches? So those are some of the broad regulatory options, but also some of the limitations involved. I think one of the things that I see happening here is that over time, the various use cases for AI and Earth observation data are really diverse. And there is, I think that we will see that there's not going to be a one-size-fits-all approach to regulating this matter, that it's going to be, that there are going to be multiple areas of regulation with differing levels of rigor. And that's what I would be looking for developing over time. So we're kind of in the first stage of I think what will be a much longer process and a longer discussion. Thank you.
Thank you, Thomas. It's kind of exciting to be at the first stage of something, but can be disorienting. So thank you for providing some structure to this topic. And I think you're also involved in the AI for EO effort at GEO. Is that correct?
Exactly. Yeah.
Great. So yeah, I think that's another venue if Thomas's talk was of interest to you. Both our subgroup and the AI for EO group in GEO are starting to look at some of these issues and how it impacts the GEO community. So thank you so much. Our fourth speaker of 5 today, and after the fifth speaker, we're going to open up for dialogue. So please, be thinking of your questions as we prepare for our next speaker, which is Kathy Fontaine. Kathy is a senior lecturer and program manager at RPI, bringing over 25 years of experience from NASA Goddard Space Flight Center, where she shaped national and international data access policies through bodies like CEOS, the Committee on Earth Observing Satellites, GEO, and the US GEO group, which is a US government effort that parallels the subject matter of GEO. At RPI, she focuses on data ethics and policy education, developing courses in ethical informatics and big data policy, while remaining active in organizations such as ESIP, AGU, ACM, and IEEE. Kathy is going to touch on how to develop an ethical mindset, particularly when legal aspects are not ready or clear. So over to you. Thank you.
Thank you very much. What I'm going to be talking about today is a completely different angle. This is based on a course that I developed a couple of years ago called Ethical Informatics. And the point here is to introduce students to ways of thinking about how decisions are made regardless of the discipline. So why are we doing this? So I give them very basic definitions. First of all, the ethics is a study of right and wrong and how we make decisions. Informatics, for our purposes, is a study of data and information technology for some sort of benefit. And so ethical informatics is how we make decisions about data. Why is this important? We've heard this a couple of times today already. There are an increasing number of professions that require ethical codes. If you violate ethical codes, you could be subject to termination. If you don't understand what what ethics is or what an ethical decision is, how will you know how to respond when someone asks you a question that just doesn't feel right? But also to understand that ethics looks different to different people. It looks different in different cultures. And that is an important concept we need to keep in our minds when we're talking internationally about Earth observations data or any international data set. So some of the foundations that we talk about are, how do ethical behaviors form and how do they change? Then what does this difference look like? We have the concept of relative application of ethics. Marriage rites and rituals in different cultures, for example, result in companionship or unions or partnerships. But a universal application of a partnership might be a marriage. So there's two different ways to look at something. Either everyone does it, I do it, my culture does it, it's relative to the context, or it's a universal truth. These are all important aspects of making a decision and understanding how other people make their decisions. So just a snippet of the frameworks that I want to talk about. Confucian ethics when you're talking about making decisions, it shapes itself around a concentric ring of respect. So the priority of that decision is based on where in that ring the person falls. Virtue theory, good character drives ethical actions, right? I'm a good person, so everything I do must be ethical. That works all the time, doesn't it? St. Thomas Aquinas was fond of espousing the law of nature, that there is a natural order to things, and an ethical decision upholds that natural order. Contractarianism is also known as social contract behavior. That's an important aspect of Earth observation data and ethics, in that social contracts often lead to laws. So a social contract is simply an expectation of behavior among a group of people. And that could be as small as a working group or as large as a country or even larger as an international body. We also have the idea of Kantian ethics and utilitarianism. These two are also extremely important. Kantian ethics believes that there is sort of a duty. It's a duty-based ethic, that there is an authority there that sets up what is appropriate and what is not appropriate. Utilitarianism, on the other hand, takes into account the stakeholders in the decision or in the instance that you're trying to decide something about, as well as their interest in the outcome. So not only who all is involved, but what do they want out of it? And this is a basis of negotiation when you talk about treaties and other forms of agreements. If you know what everybody wants, where everyone's coming from in the vernacular, and you understand what is important to them, you can come up with a solution that makes the most people happy. Now, it's not going to be 100% for everybody, but it will maximize the happiness. So let's skip a second to how these all evolved into something called the Belmont Principles. Over time, the core of many of these and other ethical frameworks gelled into four sets of principles, primarily used in human subject research, but also used when you're speaking with humans in general. The principle of autonomy, which is respect for decisions or the non-decisions of others, which means in human research, it's obtaining informed consent. And this will become important in a moment. Beneficence is just bringing out the best in others. That's reflective of utilitarianism. Non-maleficence is doing no harm. This shows up in many codes of ethics, including the medical code. And then justice, which is treating everyone fairly, equally, and impartially. Over time, when computing technology became more and more prevalent in the way we're collecting data and in the evolution or the analysis of data, the Menlo principles came about, reinforcing those other four, but then adding in respect for policy and the public interest. And this is really the one that we hang our hats on if we're talking about data policy and ethics, because the public interest can change. What is important to us, what is critical to us, what is an emergency, what is not an emergency, the political will that we've heard talked about, all of that can be lumped into the term public interest. So let's go to an example from Earth observations. The CARE principles. Data should be collected from indigenous peoples. Earth observations data included data about their boundaries, their wildlife, their every part of their existence. Those ecosystems should be designed and function in ways that enable indigenous peoples to derive benefit from the data. So if we go in doing soil moisture measurements for let's say a reservation in the southern or southwest part, western southwest part of the United States, there needs to be an understanding of the use of that measurement and the permission of those indigenous peoples, that what we're going to get back from that as indigenous people will benefit us. There's the concept of authority to control, that's the A in CARE, so that indigenous peoples' rights and interests must be recognized and their authority to control that data should be empowered. If they don't want to give up the data, they don't need to give up the data. Okay, that's a form of justice. Some indigenous peoples consider ground sacred, and any attempt to measure soil moisture, chemical makeup, any part of that data constitutes some sort of desecration of that data. And especially when it comes to minerals and other resources. And so we need to be cognizant of that and allow them to control the rights and access. Responsibility is the R from CARE. Those working with Indigenous data have a responsibility to share how those data are used to support the self-determination and collective benefit of that group. And this also speaks to accountability, which was mentioned before. And then the E is ethics. The rights and well-being, the justice, the beneficence, the non-maleficence should be the primary concern at all stages of a data life cycle across the data ecosystem when Indigenous peoples are involved. Another example, I'm not going to go into any detail on this because we've talked about open data charters before, and there may be or open data before, and this may also be covered by the next speaker, simply to say that data should be open by default. It should be timely and comprehensive. It should be usable and accessible, comparable and interoperable. It should be used to improve governance and citizen engagement and not inhibit it. And it should be for inclusive development and innovation. All of the charter and these principles also harken back to the Belmont and other frameworks from ethics from before. So if you talk about the questions with respect to any kind of data, what is the just and fair way to provide access to data? What are the rights of the human participants? There are always human participants, whether we want to believe it or not. And what are their reasonable expectations for being notified about use of their personally identifiable information? What are the moral obligations of researchers in sharing that data as a common resource pool? This is not an obvious question. From consequential ethics, how do we create the greatest utility from the data? Maximizing investment, maximizing the return on that data. This speaks to what used to be called the operationalization of data. Let's take it from research to operations. How do we find a value in this data beyond just the research value, which is not to be laughed at? What steps need to be taken to minimize harm while maximizing benefits? So we do need de-identification. We do need anonymization, licensing protections, legal protections, metadata and documentation. All of these things are based in ethical considerations for protection of the data and the people involved. And then what standards enable efficient and effective reuse of data? So these are all amazing, wonderful questions. More questions. How do data management practices conform with requirements from funding agencies? So privacy is a big deal. We've heard about this. Data management plans hopefully have addressed data privacy and security. Hopefully have addressed instances where security lapses may happen. But all funding agencies are making sure that these steps are in place now. And then what laws and regulations should govern sharing of data? When you have a combination of these two types of questions. Not only do you come up with what licenses or regulations should be administered, always taking into account the ethical frameworks, but also how they should be enacted fairly and equitably and justly, and take into account the public interest. Who deserves access and why? This is also a huge question. Open data aside, some data sets should not be open, should not be uniformly accessible. There are reasons for that. How do we understand what those reasons are and how we can protect and wall off that data so that we don't violate that reasoning? So let's talk for a second. What am I talking about when I talk about big data? It's the ability to process huge treasure troves of data and predict outcomes. It's a process that leverages massive data sets. Big data is an asset. It's a moment where data volume acquisition or velocity limits traditional tools. We talked about AI. That's a new computing technology that helps us deal with this increasing amount of data. It can also be a tactic to operate at a large scale when smaller scales are not possible. So maybe we think of big data in terms of an industry with a flow and a system and an output, but we still have the consideration that, there's a market, there's a product, but you still have to understand the ethical backdrop here. Big data is the concept that big data is ethically neutral also comes up often. We have debates in my class about whether technology is inherently ethical, whether data is inherently ethical. There are all kinds of social implications to that question, which I'm not going to go into here, but it's a huge topic. Quality, bias, and privacy are huge issues in the ethics community. Bias is built into almost everything we do. It is not possible to take bias out of the equation when you're talking about ethics, especially large language models, because part of the selection of the data set is unconsciously affected by bias. And the best we can do is recognize that and try and minimize it. Big data industry, the major ethical issues include whether data can be used for good or not. For example, facial recognition, GPS, all of these things can be used for good or for evil. And I can get these slides to you later, so we don't have to go into this, but healthcare big data for healthcare can be used for treatment of disease-borne vectors, and that includes the folding in of Earth observations, looking at a large vector spreads when we're talking about insect-borne illnesses, for instance. But you can also use it for developing scores or ways of making the playing field uneven and limiting the justice and equality that should be ethically available. Urban planning is another one. You can use it for traffic management and smart grid technology, but traffic lights are subject to hackers. You can create traffic jams. Things happen. So there's a bunch of questions here. What happens when you layer open data sets so that subjects become de-anonymized? What happens when you use a computing technology to make life easier but endanger privacy? For example, Strava got in trouble. The workout app got in trouble, and so did the U.S. Military for allowing soldiers to use devices on their arms on their hands to track their exercise. And we all know soldiers need their exercise. And so if they're running around in a map that looks like this, which is the outline of a military base, and somebody looks at that and says, oh, wait, this is the middle of a desert. There shouldn't be anything there. Why do we have exercise going on here? We just had a breach. What happens when AI gets involved? We have something in the US that's still in the works called the AI Bill of Rights. What happens when the major stakeholders change and their interests change? That's not a given, it's not a static, it's not a permanent thing. So you need to take these all into account. And then what happens when the public interest changes, right? The public is fickle. The point is that all of us have an ethical framework we use to make our decisions. Whether we realize it or not, we have one. So when we're talking to someone else about what policies are important, what laws are important, we need to understand what their basic decision-making comes from. All of us are subject to some kind of ethical framework by others. We need to understand which frameworks are showing up in which discussions so that we can make the best use of that. And with that, I will stop and turn the floor back over to the folks at the stop sharing at the moderators table. Thank you.
Thank you, Kathy, Dr. Fontaine. This is great. I see some comments in the chat that people are really enjoying these conversations, and it's a lot of expertise. So we appreciate all the speakers and all the connections between the topics. We're addressing these subjects from so many different angles. So I really appreciate that. Our fifth speaker, and our last one before we open up to the group here, is Dr. Annalisa Barla. Annalisa is an associate professor of computer science at the University of Genoa and a member of the Machine Learning Center there. She earned a master's in physics and a PhD in computer science with early work on kernel engineering and regularization methods for machine learning and image understanding. Her research spans machine learning and data visualization, focusing on robust and reproducible variable selection and on methods to understand and visualize complex structured network data with an emphasis on impactful real-world applications. And Lisa is going to talk about ethics as well and how to address it technically through metadata. Over to you. Thank you.
Hi, everyone. Thanks for having me today. I'm going to share my screen, and I hope that this is going to be sort of a high-level discussion on okay, that should be it. Please confirm that you see my screen. Okay. So the idea for today is for me to sort of navigating a couple of ideas on why AI has limitations regarding like with the aspects of ethics. So I've been working in AI, what we call AI now, for a long while, specifically machine learning. And whenever I start discussing this, I have to stop and think why we have such a high expectation. We sort of have expectation about AI that I think is very related, very much related to the term. So let's sort of first think about why we think it's intelligent and and what we mean by intelligence. So in general, I think there are many definitions, and not this is one of the many possible definitions of intelligence. In general, the idea that we link to intelligence the fact that the intelligent behavior is being able to sort of acquire knowledge and make use of it in the future in circumstances where we cannot really predict beforehand. So what is AI? Well, again, AI is an umbrella term, and there are many different approaches to solve the AI problem. So the AI per se was defined in 1956 by a bunch of scientists, where like they define AI as the branch of computer science where you want to sort of program computers to behave in a way that they can solve problems creatively. Okay, so what? Why are we here discussing AI in this audience? First of all, I'd like to point out that we have been caught in a sense by surprise in the last 3 years by the fact that specifically large language models have been have disrupted what we expected from AI in a sense. So beforehand, maybe we were expecting more like robots taking over, but like ChatGPT was like a sensation for everybody and the likes, obviously. But AI per se has been around for a long while, so it's not really a surprise that this is kind of starting to work. So for us that we work in this field, is kind of like makes a lot of sense. We have been discussing cybernetics and like from the 40s in the last century. So von Neumann discussing machines that could think, and then like a bunch of people, like including Claude Shannon, discussing how to solve problems complex as chess or checkers by solving them with very different approaches from what we are using right now. So they were aiming at solving the problem of chess or checkers by like defining search problems, meaning that they were attempting to define how to solve these kind of problems by listing all the possible moves and counter moves. That was like computationally very demanding and it's unfeasible. So, but in theory, that's doable. So that was the approach back then to artificial intelligence. It's still called artificial intelligence. It's a very different type of artificial intelligence with respect to what we have now. So then they discussed it, like the term was born in 1956. And finally, at the very beginning of the 60s, we started thinking about strategies that were depending on data. So before, there were like more approaches defined even on just theoretically on rules and knowing exactly the entire domain where we want the machine to work and behave intelligently. Now we think like from the 60s on, it was clear that it couldn't be done efficiently in that way. And therefore we started thinking of, especially Arthur Samuel at MIT, started discussing methods that were data-driven. And so learning by examples, that's the other term that I like to use. So the idea that you don't explicit program anything, the program just had to learn from the data using just a bunch of data and infer the patterns from the data that can be used as rules for understanding the world or playing checkers, for example. So that's the main, that's where like what we know now as AI started. Skipping ahead a few decades, now we think of web crawlers in the 90s and then like the search engines, and finally Deep Blue in 1997 win against Kasparov. So that's like a few decades in a minute to understand that AI like is a very broad term umbrella that dates a few decades back. But now we have a sudden transformation ongoing that we are observing these methods that are really outperforming humans. So this is a very popular plot where we see that human performance is the zero, and that we have many different AIs specialized in, for example, image recognition or data comprehension that are now way above the human performance. 3 ingredients for the transformation: data deluge, and that's where we are like, this is the topic that we are discussing today. The availability of many data it's one of the key ingredients that allow this transformation. High performance computing, definitely, it's the capability of big data center and GPUs has led to this transformation. And then deep learning. So the part of machine learning where we can exploit the power of data of neural networks. And in particular, I cannot not mention transformers that were provided to the community by a paper published in 2017 by Google researchers. And that's basically the deep learning architecture that is at the basis of the large language models as we know them today. So AI really works. So it's really working, and now we are kind of mixing. So deep learning is a part of it. But this is what has allowed us to solve unsolved problems in science. Like this is a three-dimensional structure of a protein, and that's allowed 3 scientists to win the Nobel Prize in 2024. And one of the 3 scientists was a deep learning specialist that had been working in DeepMind. So it's really pervasive. The AI that we know right now is really pervasive in many, many fields of science and in many, many fields of technology. So here is another striking example, like radiology and medical imaging, and the fact that we are now able to sort of process right away the machine, like that takes like does the MRI is also providing sort of a screen of what is going on in the body, just like suggesting the doctor where to look. Self-driving cars, and I think these are the most striking examples, save assigned from generative AI. So this is like image generation, and we have a daily experience of language generation as well. So these are the ingredients: data, computation, and deep learning. But the data part, I think it's one of the most, if not the most relevant one for guaranteeing us to having an AI that works. In particular, data is so we tend to think that data is available everywhere, but it's usually very difficult, especially in large institutions, to make use of data if the data collection has not been designed in a way that the data is there and it's reusable by machines and algorithms. So this is one part which I think is personally think it's definitely overlooked. We tend to have we use data that is in tabular format, and we think, okay, then if it's in tabular format, it's fine, and it's definitely not. The fact that the data is going to be used by another machine, so if data is readable by a human, it doesn't necessarily mean that it's understandable by an algorithm. So the data quality, I think it's a key factor in producing AI that's going to change the world as we know it. There is a saying in computer science, I think most of you know it, this is garbage in, garbage out. So I think data quality is still a key factor that is very overlooked in this field. So how to leverage the power of data? The organizations that allow, like the need to use data for improving themselves, the processes, or like the services that they offer, should embark the journey toward data exploitation, having in mind that the high data quality is one of the key factors, and the process redesign is possibly one of the strategies to obtain better data. So I think there has been like a hype a few years back about digitalization. So where everybody was like focused on digitalizing processes that were normally human analogic processes. And I've observed in my experience many times the fact that like these processes have been not redesigned, but just transposed from the process that was the human governed process to a digital process, which is exactly mirroring the steps that were there before. This has usually led to producing data which are digitalized, but not necessarily designed for being reused or at the basis of machine learning models. So high data quality and process redesign, I think it's the two steps that we should discuss in this kind of audience. And then the third ingredient is data culture. So to prevent the resistance to change, in fact, that would be best to actually reskill and upskill people participating to the data collection in understanding why it's very important to produce data that is high quality. Last 2 minutes of my presentation are going to be discussing bias. So when we even if you focus on data collection and how to get like very high quality data, nevertheless, we should also take into account the fact that AI is usually like by design, because it's data driven, learns also the bias that is stored in data. And we have had a few striking examples on why this is not, but like we should be aware of the limitations of AI in this sense. So, for example, this is an old Twitter when X was still called Twitter, where like the translation from Finnish to English, Finnish is and I apologize, I don't speak Finnish, so, but the language has neutral pronouns. So this sentence here is composed by like the paragraph is composed by short sentences where we have a pronoun and a verb. And we can observe that the activities that are related to investing, playing sports, driving a car have been translated with a male pronoun, whereas, like, for example, taking care of the kids has been translated with a female pronoun. This is a distortion that we can observe, and it's clearly a distortion from the language model behind the translation. Is this what we expected from, like, should we correct? And what is the extension of the alignment problem? Should we try to correct a posteriori the AI model? Should we be aware of the fact that because these large language models have been reading the entire internet and some parts of the literature, have possibly learned the societal distortion where actually females are more likely to take care of the kids? So this is an open question that I leave up to discussion. And we have had many other examples, like, for example, the bias into deciding if, like, parole was more likely to be assigned to white defendants because the data behind the AI algorithm was like distorted in some way. So users should be aware of the limitation aspects of AI, and service providers should disclose model limitation. And this is very, very important and it's related to the last part that I want to comment, which is like regulations. So we should be aware of the fact that data can be distorted in several ways, and therefore the models that have been learned about them. So there will be distortion that derive from prejudice and prototypes and categorical and the culture limitation that we have. So when we gather some data to define a learning model, we're going to define the data set depending on our own prior knowledge. So there will be human biases in data collection, and also there will be human biases in data annotation, which is like the metadata that we use to define better machine learning models. Consequences, well, we would, like, as people working in AI, would like people to trust models. So if we don't make the people aware, we don't correct these aspects, we'll end up like having AIs which is like that commits discriminations and unfair outcomes, and definitely erosion of trust by the users at all kinds. And so guidelines. So we resort to guidelines that is the fairness, accountability, the privacy, all the guidelines that also the EU has been discussing with the AI Act. Not just the EU, but definitely we have to mention it, the AI Act and the AI risk management framework and recommendation from the UNESCO and so on. So there are limitations, and we have become aware of them, and therefore, like, the regulations are finally sort of catching up with the technology, hopefully, towards something which we would like to call sustainable AI, and that is like designed for the common goods. There are principles, so we have to navigate and design AIs that are trying, like the community of AI should somewhat embark and adopt this principle in order for, like, navigating navigating the complexity of the ethical limitations. Okay, so this is the last slide I wanted to share with you, and I hope this could be discussed further in the next round of discussions. Thank you for having me again.
Thank you, Dr. Varla, and thank you to all the speakers. I think this has been fantastic, and I think just judging from some of the comments we've received, people have really appreciated you all sharing your expertise and highlighting, I think, some of the things that GEO doesn't always think about, and not because, you know, it's not important, but because we often are focused on, I think, the scientific and technical aspects of it. So this has been great for me. I've really appreciated it, and I think the group has as well. So thank you to the speakers. Open up the floor to questions. We don't have too much time, but I think that's because we had such great speakers and so many of them. So I hope you all don't mind that I had as much time. But again, if you have a question, please put it in the chat, and I will call on as many as we can. Bente, I saw a first question from you. If you won't mind kicking us off.
Well, hello everyone. I think I was bombarding the chat here with several questions. I don't remember which one I was asking first, but I'm sitting here. Thank you to all the speakers, by the way. Derek, you're right, and all those who have commented in the chat. Thank you very much. I do really appreciate. It's been a very rich set of presentations. Now, many of you used AI as an example of showing you, or the subject of your stories. But in Earth observation, we have many others, many other analytics services, applications, and usage. And what we are after here is to provide some guidelines, some implementation guidelines that take into account these different aspects that you are mentioning. And I was wondering if there are anything that we can extract from, and this is a question, open question to all speakers, anything we can extract as implementation guidelines directly related to Earth observations, because many of you were, there was a plethora of different types of data. But is there anything particular that you can think of that would apply and that will be helpful for anybody using Earth observation specifically?
I can offer a start to that. One of the guidelines that keeps coming up in AI is keep a human in the loop. And because AI is such a broad term, it's really hard to say, here's how it's applicable to EO. I would say that one of the strengths of artificial intelligence processes and tools is that they help us understand patterns. And in order to do that, we need to ingest enormous amounts of data. The best thing we can do, regardless of whether it's EO or not, is make sure that we're not biasing our data sets. Because, as Annalisa pointed out, we've got some really bad outcomes of algorithms that, with all the best intention in the world, chose the wrong data set without knowing it, and then had to go back and fix that. So understanding that we need to be aware and comprehensive and understand the bias that we inherently have and try and minimize that when we're looking at huge amounts of data in order to identify a pattern would be something we could recommend.
Yeah, so keep the human in the loop. I'm trying to be very practical, Kathy, because we are developing, concrete implementation guidelines, and that could be like a general sort of advice in such a guidelines, I suppose. Yeah, thank you.
May I add the comment? Thank you. I think also inevitably there will be some kind of bias anyway. Like data-driven models are learning that, like, in a way, also the bias. It's kind of built in how they work. I think the awareness of the limitations of the model, I think it's something that we can actively work on, like spreading like the data culture. I call it data culture. We can call it wherever you want, like more AI culture, or like the expectations that we need to have, like the correct expectation in a sense. I think that would be a starting point in like being aware of the fact that these are powerful tools, and I personally couldn't imagine not using AI all the time. Should I expect what I expect? Knowing what to expect, I think it's a starting point in understanding how we can trust the outputs.
If I can add something also, I think in Earth observation, especially in my field, what's happening is you need a gold standard. Thus, when you have processing a large amount of data, big data, then the output has to be checked, thus quality check at the entrance of the AI and outside at the output, and the output should be checked with what we call a gold standard, and that it can be a value which has been discussed by a quorum of experts, or it can be a data set which has been improved over years, knowing all the bias in it. Thus, yes, you're right. We need to have still the human hand in the process, and also we need to detect large biases as soon as possible. Thus, there is a lot of work on exactly the AI algorithm to be able to do that.
Yeah, I also want to chime in that one of the case studies I use in my class is the use of AI simply because it's AI. Jumping on that bandwagon doesn't necessarily get you anything. So AI is a suite of tools. If one of those tools is appropriate, use it. If not, don't use it simply because you want to be on a bandwagon. It's either appropriate or not appropriate.
Yeah, and I would just chime in as well. I mean, I think that the state of there's enough guidance, there's enough thinking out there as to what the responsible use of AI for Earth observation data is today. And I would suggest that it's appropriate for GEO to think about including some basic sets of principles in the instruments and guidance that GEO issues. And right now, I don't think there is anything like that. And so is it something that could be added to existing things, even at even on a basic level, with the idea of maybe developing things further over time?
Yeah, Thomas, so just for your information also, we do have the implementation guidelines for the data management principles, the geodata management principles. And that's where when we were planning this dialogue series, we were discussing, it's not only so updating those guidelines, plus, the open knowledge is much bigger. It's not only the data, it's also infrastructure, hardware, software, etc. So there's a whole plethora of things that we need to look at, but including revising, updating the implementation guideline for the geodata management principles. Yeah, thanks for that.
Sure.
Marie-Francois?
Yes. So, I work with OGC, which is a standard organization for location data. And thinking about standards, there is the ISO 19157, which is about the quality of the data. For instance, when you qualify a map and the detail of the pixels, you can qualify the quality of each pixel. But when you talk about the quality of a process, because there are some EO products where you cannot qualify each product. For instance, if you make a radar image, it's 5 minutes. Or if you make a remote sensing combining several channels, each 15 minutes, you cannot qualify each 15 minutes each of the products and each of the pixels. So in fact, you qualify the process, the production process, and then you say, well, the production process is good. If the data, the input data is good, the result is good. And in the same way that in the data and working group, we consider reviewing our guidance for data management principles to see if they are still conformant with AI. We consider AI is a technology, and our guidances are supposed to be compatible with any type of technology, to be agnostic of the technology. And I think it would be good to review these standards to make sure that they also address the quality of the AI and that they do not require additional, for instance, metadata in the description of the process, of the quality process for AI. And thinking about what Kathy said, well, thank you to all the speakers. I mean, your presentation were just very, very stimulating and emulating for the brainstorming. I think that I wonder if there is any process to make a type of guidances to make sure that what you do is ethically acceptable. I cannot say correct because, as you said, ethics can depend on the location and so on, but at least has been approved with a certain level of basic ethics. If people have ever wondered about it when they did it. And I'm not sure there is anything like that.
Oh, yeah, there is.
Okay, great.
There's, since 2017, there have been a bunch of workshops and results, and I can share that with you guys. So there are a lot of ideas floating out there about ethical use of AI.
Great. Thanks.
Great. I know we are over time. I really appreciate everyone, our speakers and our participants joining. Yeah, I don't see any other in the chat, but if anybody has one now, yes, please raise your hand. Well, yeah, once again, thank you so much to the speakers. I know your time is valuable, and I know this was a quick turnaround on this, but I'm really pleased on how it came about. And thank you as well to my colleagues in GEO and our subgroup for all the work you put together and finding these excellent speakers. And thank you to the participants for sticking around for so long too. As I mentioned, if you have any interest in this group, please reach out. There is a process for membership, and I'll have to defer to our GEO Secretariat staff for support on what that looks like. But in general, I think this is something that clearly has value to the GEO community based on the participation today. So thank you all. And there will be a recording, and there are future dialogue series as well that was put in the chat. So please look out for those. Bente, Marie-Francois, anything else from you all?
Well, I hope we have convinced among the audience all people working interested in EO that legal aspects and ethical aspects are very important and they have to be considered from the start of the developments, and that people with legal background, that we need you.
We need you. Yeah.
And it doesn't necessarily mean just a lawyer, but lawyers are welcome. But law, policy, ethics, yes, more generally. So yes.
Thank you very much.
Thank you all.